Hey guys, thanks for watching. So in this video, we're going to look at player missile graphics on the Atari 8-bit computer in BASIC. We're going to actually construct a spaceship and we're going to move it around on the screen and we're going to change the color and we're going to learn about all the things that are necessary to set up the player missile graphics registers in BASIC and actually create a basic ship, like I said, and move it around. So this is going to be getting into the meat and potatoes of doing animation on the Atari 8-bit computer using the player missile graphics system. Now the player missile graphics on the Atari are very powerful. When the Atari first came out with this technology, there really wasn't another computer around that could compete with it as far as the ease of use of moving sprites around on the screen, and getting the animation done with very few lines of code. Basically, you're given 4 sprites, or what is known as players in the Atari world. These 4 sprites can have colors that are completely independent of what's going on in the background or the playfield. So you get an additional set of colors, if you will, when using the players. Now you get four players and you get 4 missiles. The players are 8 bits wide by 256 bytes high. So you can have a player that's the height of the screen, 8 bits wide. The missiles are 2 bits wide, and the reason why you have player missiles is because in the old days when you had Space Invaders, it was players and missiles, so they kind of coined the name player missiles, so you could have players and then the players shoot missiles. That's where the name came from anyway. So like I said, on the Atari, the player missile system was developed. It's very easy to use, it's very powerful. And we're going to take a look at it today in BASIC and how to get it started. And then as we get more involved in the player missile graphics in the next set of videos, what I'd like to do is work up to creating a game, a full-fledged game that we write in BASIC. And we're going to see the pros and cons of that, of writing the game in BASIC. We might actually do some of the parts of the game in assembly language and then use that code in the BASIC for speed. Maybe moving the player up and down on the screen and controlling the firing sequences. But once we get all that taken care of and we got a full-fledged game, what I'd like to do is take that basic game and port it to assembly language. And that'll be the holy grail for us, because now we'll have a game that we've prototyped pretty much in BASIC and worked all the kinks out of it. And now we can port it to assembly language and have full speed and full power and rocking and rolling, and it's going to be really exciting, guys. So before we get into the code, let's take a brief look at the history of player missile graphics and how it's controlled in memory, how we set up the memory. And don't worry if you can't follow along with every bit of it, as we talk about it. Once we get into the code and we start going line by line, I'm going to describe to you what each function in the player missile graphics system does. And once you start working with it, it'll all become clear and it'll be very easy to understand. So let's take a look at player missile graphics and how they work, and then we'll get into the code. So what exactly are player missile graphics in the Atari computer? It's a system designed by the engineers to allow the movement of sprites easily around the screen, independently of other objects that are on the screen and independent of the graphics mode that you're in. The sprites can take on colors of their own, they can be moved independently, and the system can also tell you or detect collisions between the sprites. You also are given 4 missiles. The 4 missiles are also 4 other objects that can be moved independently of the players. They're limited to 2 bits in width, but they can be combined to make a 5th player. So with this powerful technology at your fingertips, it makes it really easy to create games and animation on the Atari computer using minimal overhead of the CPU and minimal lines of code. You're probably familiar with this game, Donkey Kong. It was very popular back in the 80s. Well, guess what? Mario, along with the barrels and the fireballs that appear, are all part of the player missile graphics subsystem. They're being animated using player missile graphics, and when Mario gets struck by a barrel, that's called a collision. Pac-Man is another popular game that you've probably played, and you can see the same type of movement here with the ghosts, which are probably players, and the Pac-Man, which is probably the missiles, all 4 missiles combined together to make the Pac-Man. Now I'm not 100% sure of that, but in theory that could be put together that way to make this game happen. So again, player missile graphics are everywhere in the games that we play and the programs that we use. In this diagram, we can see a simple player as a vertical film strip, if you will, along a particular horizontal position. So that 8 bits wide, 256 lines tall, can all be filled in or left blank for your player. So picture your players as a vertical strip moving across the screen horizontally, and the bitmap data within that strip being moved in memory as the player moves up and down. In this very basic example, you can see one player, which has all of its data filled in, 255, being moved across the screen backwards and forwards. In the next example, we have the same player, except instead of having all of its bitmap data filled in from top to bottom, we only have the middle section shaped as a spaceship. If you think of the Atari's memory map, you have top of memory. You typically have your character set, Screen Antic 5, display list, and so on. Sort of this similar stack of programs and data within the memory. We're going to position the player missile graphics in the upper 2K of the top of memory. And there's a way to do that in code, which I will show you in BASIC. It basically involves getting the top of the memory using peak 106 and then calculating 2K backwards and setting that new top of memory 2K below that and allocating that area for our player missile graphics objects. The other thing to understand when it comes to player missile graphics is there's 2 modes of resolution: double line resolution and single line resolution. Without getting too in-depth in discussion about it now, just remember that double line resolution requires less memory, but it's also taking up 2 lines for every pixel on the screen, whereas single resolution takes more memory, but it only uses a single line per pixel. What that means is the single line resolution is more detailed, it's finer in its resolution, which is also the reason why it requires more memory. When we design our players, we design them with a bitmap structure in mind. In other words, we want to have 8 bits wide and 256 lines tall, which would give us a full character. Now, you don't always plan, nor do you hardly ever use all 256 lines of the character, because what you would end up with is a tall block moving around the screen, which wouldn't define very much. But if you look at figure 2, you can see we have a spaceship, and to define that spaceship, we're going to use the values 16, 56, 56, 124, 108, and 68, which gives us that spaceship structure binarily using the 7 bits. Same as the alien below in figure 3, you can see the top of the alien, which is a 60 in decimal, which equates to bits 3, 4, 5, and 6 being turned on. Now, having these decimal numbers handy, we're going to have to write them down once we design our character, because we're going to have to transpose those into our basic program in order to load them into memory and create the character for our players. So in basic summary, we're going to create a 2K block of memory that's going to have a base. We're going to call it the PM base, and it's going to start whatever address PM base is and extend 2048 characters up and beyond that PM base. We'll reference our missiles by adding 768 to the PM base, and we will access player 1 by adding 1024 to the PM base address, and so forth. And this is going to allow us to individually poke values for player 0, player 1, player 2, player 3, and or missile 0, missile 1, missile 2, and missile 3 to define those characters. Once we have those characters defined in memory, we can set the color for them, we can control their horizontal position, and we can move them vertically within the vertical space of the screen by moving the data within the memory address space of the 256 bytes for each player. Okay, so here we are at the Atari 130XE, and I've got some code loaded here that I want to run and let everyone see what it does first. So what this code is doing is it's moving a player 0, back and forth across the screen as fast as BASIC can do it. And you can probably see a little distortion in the vertical lines as it's doing that because it's not exactly the most efficient at moving, the players back and forth, BASIC that is, okay? So what I'm going to do is I'm going to put a delay in here so you can actually see it moving a little slower. And don't worry, we're going to go over this code top to bottom so that we have a good idea of what's happening. Actually, we don't have a delay in here, so let's go ahead and put a delay in here under each line. Don't worry, we're going to talk about the code. I just wanted you to see the movement a little bit slower. Okay? So the reason why I wanted you to see this before we start coding so you can get an idea in your mind what we're shooting for as far as what we're going to be looking for the code to do and what it's ultimately going to be on the screen. Eventually we'll turn this bar into a spaceship and I'll show you exactly how we do that. So in the meantime, let's start with lines 1 through 26. And did I forget how to do this in BASIC? Yeah, it's a comma. All right. So the first line in our code is a remark that basically says this is a player missile intro. Line 20 is a remark. The first thing we need to do when we're going to be programming in player missile graphics is we need to do what's called setting the PM base, okay? Now this base is going to be, as we talked about before, it's going to be an area in memory near the top of memory where we're going to allocate 2K of memory for our player missile graphics. So the first thing we're going to do is we're going to peek into location 106. And if we look at that location here in BASIC, we see the decimal value 160. That is a page number in memory that is a multiple of 256 that tells us where the operating system thinks the top of memory is. So if we did 160 times 256, that's the actual memory address in the top of memory. Okay, so what we want to do is we want to allocate 2048 bytes, which happens to be a multiple of 256 times 8, 2048. So that's why we're saying to ourselves that we want the new top of memory to be whatever it is minus 8 pages. Okay, so we're basically taking the top of memory and we're backing it up 8 pages, and that's the block of memory that we're going to use for our player missile graphics. So in order for us to designate that area of memory as ours for our player missile graphics, we need to tell the operating system, okay, guess what? The top of memory is now down here, 2K less. And that's what we're doing in line 23. We're poking back into location 106, the new top, which is the new page number of where the top of memory is. Okay, does everyone see what that's doing? Let me just highlight those two lines so that they are by themselves. Okay, we're getting the top of memory, subtracting 8 pages from it, and poking it back into 106. The next thing we're going to do is we're going to change our graphics mode, and I'm going to go ahead and set this to 0. Because everyone knows what graphics mode 0 does. And actually, let's run that and make sure that still works the way we think it should work. And it does. Okay, I just wanted to make sure. Now, the nice thing about player missile graphics is the graphics mode is independent of the player missile graphics colors, movement, direction. They're kind of like sitting on top of the graphics mode. So you can have any one of your graphics modes below the player missile graphics, and they're independent of that, okay? All right, so now we've got our new top of memory. We've decided what graphics mode that we're going to use. Now what we need to do is we need to determine what is the address in memory for our base of our player missile graphics. So we started at the top, we backed the top of memory back down by 2K. Now we want the address of this beginning of that 2K. And the very simple, the way we do that is we take that new top number and we multiply it times 256, and that gives us what is called our player missile base graphics address. I've abbreviated it here, PB. So this is where we're going to be using PB throughout this demonstration to reference the beginning of our player missile graphics data. All right, so we found the new top of memory, we've changed our graphics, we've got our player missile base. Now, Atari requires you to poke location 54279 with the new top value. That is not the memory address of your base for the player missile graphics. It is that number that we poked into 106, excuse me, that tells the operating system this is where our player missile graphics is starting, page number wise. Okay, very important. A lot of people tend to put the PB number there, which is the actual address, and that's not what 54279 is looking for. Okay. Now the next location that we need to change is 559. We need to poke a 62 here for single line graphics, and I believe it's a 48 for double line graphics. This is what tells the player missile graphics system if we're using single line resolution or double line resolution. Well, obviously we're using single line resolution, so we're going to use a 62. The next poke that we need to do is location 53277. We need to poke a 3 there, and that tells the system we want to enable the player missile graphics system. Okay, again, these pokes have to be done. If you miss any one of these, the player missile graphics will not work. Let's move on down to line number 110. Poke location 623. Now I'm going to pull up a graphic here that talks about location 623. Location 623 is what gives certain players priority over other players and or missiles and or the playfield. Now that was a lot to say. Let me see if I explain that in layman's terms. Basically what you can do with player missile graphics is you can have a background, and then you can have players moving in front of that background. But you could also have different colors in the background and have players moving behind certain colors and showing in front of certain colors. So you can have a player that goes in front of trees, but behind walls. The value that we poke here in 623 is what controls that playfield priority or the player priority. You might have player 0 passing in front of player 1 or vice versa, or you might have the missiles passing in front of the players. So there's all kinds of priority you can give here for the players. We're going to go ahead and give all the players priority by poking 1 just for our sample, hitting this. Okay? So let's go on to line number 180. Now 180, I'm sorry, did we already do that? Enable player missile graphics? Yep, we've got a bug in here already, guys, but that's okay because I'm going to go ahead and fix that. It looks like I've got the enable player missile graphics in here twice, but that's no problem. We're going to get rid of 180, and we're going to get rid of 190 because that's just duplicate code. Let's run that, make sure it still works. It does. I'll explain that drawing to you in a second as to why it's doing that. Okay. Excuse me. All right, so let's go back down to, let's list lines 200 forward. Okay, so the next thing we need to do is we need to pick a color for our player 0. And the way we pick the color is we poke location 704 with the color that we want to choose for that player. I'm going to bring up a slide now where we talk about how we choose that color. Okay. Okay, so now that we've chosen our color for the player, we are going to actually set the initial exposition for player 0. Now, typically, you would want to have this exposition or this exposition off of the screen, far enough either to the left or the right where the player is not showing. For this demonstration purpose, I've chose 120, which is somewhat in the middle of the screen, so that we can actually see the player when we run the program initially. Next thing we're going to do is we're going to set the width of player 0. And this is where we're actually going to control the width of the player. There's 3 settings you can set for players: 0 normal, 1 double, or 3 quadruple. And the designers built this capability in there for you to be able to enlarge a player in 3 stages. It's almost like magnifying the player 3 times to almost give, for example, spaceships like they did in Star Raiders, they give it the ability to make the ship look bigger as it's flying through the store field, to give you the impression that it's getting closer or you're getting closer to it. So we'll talk about that a little bit later on, but for right now, we're going to poke location 53256 with a 0, which stands for the normal width. Okay, let's move on to line 320. So 320 says clear player 0 memory. So as you might recall back from one of our slides, player 1, the memory location of player 1 in single line resolution starts at the player base address plus 1024. That moves us beyond the unused memory, beyond the missiles, and at the starting address for player 0 in this case. So P1, which represents our player 0, which in reality I should probably make this a P0 just to make it more compatible with what we're talking about. Actually, you know what? I'm not going to change that for right now because I don't want to break the code, but we should probably have that as a 0 just for consistency, but we're going to leave it right now. So anyway, player 1, we're going to be the player base plus 1024. Now, this is something that you really need to do for each one of your players or missiles, because remember, we've told the computer where in memory we want the player missile graphics to be designated, but we don't know what's in that memory. There could be garbage there, there could be unknown information. So it's really important that you go through the memory, clear it out, and the way you do that is you set up a loop. Now that we've got our starting address for player 1, we know that each one of our players is 256 bytes in size because we're in single line resolution graphics. So we need to loop 256 times, and we need to poke a 0 into each one of those memory address locations to clear out the garbage there. And the way you know that that is working, again, it's the reason why I had the player on the screen to start with. When I run this program, you'll see that. Did you see that bar go across the screen? Let's do it again. You're going to see some purple fragments in the middle of the screen, and then you'll see almost like a wiping effect going down and clearing them. Did everybody see that? Let's do that one more time. See that wiping effect right there? Okay, that's what I'm talking about. That's what this is doing. This is going through and it's clearing out the garbage that is in that player memory. This is very slow and basic. I mean, you can obviously see it happening on the screen. This is one of those routines that we're going to want to convert to assembly language and call it from basic using assembly to get that fast clearing so that it doesn't slow down the basic operation. This is one of those operations that we want to do in assembly language, machine language. And in the next episode, I'll show you how we do that, and it'll clear the player memory out instantly. Okay, but I wanted you to see that on the screen so you could see what it's doing. Now, the next thing we need to do is we need to define our player. Now, first time around, what I'm doing is I'm going through the entire player memory again, player 1 address to player 1 address plus, this should actually be 256. The second line here where I'm reading data is marked out because what I'm doing is I'm poking directly in there 255. Okay, 255 is FF, which is a full value. And I'm cycling through and I'm filling that player with 255, which is the reason why when I run, you see on the screen clear the garbage, and then immediately see filling the player top to bottom with FF 255. Does everybody see how that worked? That's the reason why our player looks like a solid band going from the top of the screen to the bottom. Again, I did that for demonstration purposes. I wanted you to see the entire player 1 object filled from top to bottom, and how large you can make each one of your players if need be. All right? So the next thing we're doing is once we fill the player data, then we are going to loop through 10 to 220. And now what this is going to do is this is going to move the player across the screen from left to right. This is the x-axis, the horizontal axis. So what we're doing is we're saying from 10 to 220, 10 is a location that's low enough off the screen. 220 is also a location that's off the screen. So you're going to see the player start from beyond the screen, moving across the screen, and then move off of the screen. And we've got a short delay that we just put in 1 to 10 that slows that process down. And then the way you move player 0 is you poke location 53248 with the X location you're looking for. 53248 is for player 0, 53249 player 1, and so on. There's a poke memory location for each player's X coordinate. So basically we're moving the player from 10 to 220. Once that's done, we're coming on 460 and we're moving the player from 220 back to 10 in the opposite direction. And then we're looping back to 430 where we move the player left to right, right to left, left to right, right to left. So let's see that one more time. We're wiping the garbage, we're filling in the player, and now we're moving the player left to right. Now if I break this program, you can see that the player is on the screen. And I can actually move him live right here in BASIC by poking the X value. Does everybody see that? Because this player graphic, this player is independent of the display. We can list our program here, and that player is turned on, and he is there on the screen until we turn him off. Very interesting, very cool. Player missile graphics are independent of the graphics mode that you're in. They are their own objects. They're getting controlled by the CTIA or GTI chip, and it's handling the function of moving those players and those missiles around independently. Okay? So let's reset, which clears out that player and turns it off. So let's start once again from the top. We find the new top of memory by peeking 106, subtracting 8 pages from it. We poke that back into 106 to reset that top, letting the operating system know, hey, here is your new top of RAM. We set the graphics mode, whatever graphics mode we're going to be using, and we let the player missile graphics base address be that new top times 256. PB is now the address of the new player missile graphics block of 2K memory. We then poke 54279 with that new top page. We choose single line resolution by poking 559 with a 62. We enable the player missile graphics by poking 53277 with a 3. And we give all the players priority with a 623-1. We set the player for the color for player 0. That's another thing we should try. Let's try changing the color on the fly. So 704 is our color location for that player. So let's let this guy come across the screen a little bit. Let's go ahead and poke 704 with another value. Let's say 50. See the color change? And remember, this value is actually a color plus a luminance combined into one. Okay, everybody see how that works? All right, so how do we change that band to an actual rocket ship or a player object that we can actually design and use for a game? So let's go back to 390 where we're filling the player data now. Remember we talked about the player being 256 lines tall, 8 bits wide, and that's the reason why we filled the entire vertical strip of the player here with 255s so we could see the whole player in action. Well, we don't want to fill the entire player. We want the player somewhat, for our sample here, in the middle of that band. So let's start at the beginning of player 1's address, and let's add 120 to it, which will bring us down 120 lines from the top. And let's fill it to the player's address plus 134, which is roughly 14 lines in height for our player. So 120 to 134. And now I've got some player data, excuse me, already set up in some data statements below. And what we're going to do is we're going to poke those values into the player data. And let's run this and see what we get. Everybody see that now? We actually have our spaceship going across the screen. Very cool. And now you'll see them reverse, because now we're starting from the 220 location and reversing back to 10 this way. Okay? Again, we can stop the program, play around with some colors. We can continue the program. Very cool. Now we could easily set up players. We have player 0. We can set up players 1, 2, and 3, and have 4 of these spaceships going across the screen independently of each other, with different colors, different speeds, different places in the vertical axis. You name it. All right. Everyone see how that works? So as you can see, with a very small amount of code, we have enabled the player missile graphics, we've turned them on, we've defined our player, we've set the graphic size. Oh, there's another thing I wanted to show you. I wanted to talk about the width of player 53256. Let's try quadrupling the size of that player, okay? So let's run it. And we're going to break it here when he hits the middle. So I believe it was 53256. So let's poke 53256, comma 3 for quadruple. Watch what happens to our spaceship. See how big he got? See how large he did? Now we've got this quadruple size spaceship. And we didn't have to redefine any data. All we had to do was poke one location to get that to happen. Now we can do double size, poke 53256 with a 1 for double. Now we've got a double size spaceship, okay? Now if we want to move him faster, all we have to do is take out our delay, or decrease our delay. Let's half our delay to 5. Okay, let's see how much faster we get now. There we go. So we got a little bit faster there. Now the other thing I want to show you is, let's remove the code where we actually clear out the memory of player 0. And this is going to show you why it's very important that you have to do this. So let's remark out this line. Let's remark out this line. And let's remark out this line. Now you're going to see we're going to end up with a character, but we also have the garbage accompanied with it. That's a perfect example of why we need to zero out the memory for each player missile object we're going to use before we actually use it, because more than likely there's going to be trash in the memory location for that object. Did everybody see that? Okay, let's put that back. Oh, let's not do that. Make sure we didn't break anything. All right. The other thing we can do too is we can change the graphics mode here. Let's do this, and let's also set the background color to black, shall we? There we go. A little more spacey. If we were savvy enough to have a star field flying in the background, that would be cool, but that's obviously going to be a more advanced subject. So anyway, guys, there you have it. Player missile graphics introduction. Very easy to set up, very easy to set up in memory, very easy to create the characters, very easy to move in horizontal directions. Now, moving in the Y direction is a little bit more involved, but I'll show you that in the next episode. It's not too bad, and we'll also get into putting some more players on the screen and have some missiles fly across as well. And what we're doing is we're going to slowly, incrementally build towards creating our own game. I hope you guys enjoyed this. Please like, subscribe, and give me some comments below if there's anything that you want to see, or if you need anything else explained from this code. I'll be happy to comment that and explain it to you. But until the next episode, keep programming. Go Atari. All right, so there you have it. Introduction to player missile graphics, and we actually got some code working in Atari Basic. So if you like this video, make sure you let me know. Make sure you like, make sure you subscribe to the channel. Give me some comments down below. Let me know what you like, what you don't like, if you want me to continue this series. I think most people want to see this type of programming on this channel. Probably more so assembly than basic, but basic is a good starting point to get your feet wet and to learn the technology, and then just move that logic over to assembly language for speed and power. And that's kind of how I work it here. So anyway, I'll see you in the next video where we progress with this sample. I'm going to add some more code to it and get some backgrounds drawn in there, and we'll make our spaceship, you know, move up and down and be controlled by the joystick, and we're going to build upon it that way. So till the next video, keep programming. Go Atari.